Hello, welcome to my channel. My name is Nilesh. In this video, we are going to see how to upgrade .NET Core base images, the Docker images from 2.1 version to 3.0. So I'll be using the same application which I have used in earlier videos. This is about .NET Core API, web API, which acts as a producer for producing certain number of messages. These are configured number of messages, and these messages are pushed onto a RabbitMQ queue. And then there is a .NET consumers which consume these messages. These are again configurable, and we can configure them to a certain number of batch size, and based on that, the number of consumers, they get scaled automatically. So the source code for this is available on my GitHub repo, and you can have a look at the link here. I'll also provide a link in the description of the video. So without any further delay, let's go on to the command line and start with the demo. Let me show the code which I'll be using. So if you look at my repository, which is named as the PD Tech Fest, I've been using .NET Core 2.1 base images for this. So in this repo, I've got a Docker Compose build file, which is building my Docker images for the producer and the consumer. And this looks at the context, which is the Docker file for those individual projects. Let's go and look at the first one, which is producer. So if you look at the first line, which refers to the base image, we are referring to Microsoft .NET image, and the tag for this is 2.1 .300 SDK image. So I'm using a multi-stage Docker build here, where the first stage is for building my application, and then once the application is built, I have a runtime image which is based on .NET 2.1 aspnetcore runtime tag. So I don't need all the build tools or the debug tools once the image is built or once the application is built. So I take the output of my release stage or the build stage, and I put that output into the runtime image, and then I create the image which needs to be deployed using this runtime version of the image. Same thing happens for the consumer as well, but the base image is different here, and I'm using aspnetcore build image in case of the consumer, which is an exe, whereas the producer is an API or a web API. So this is using .NET 2.1 .300 SDK, and the consumer is using .NET Core build image as the build environment. And for the moment, just ignore this commented line, which is referring to the SDK 3.0. We'll come to that slightly later in this video. Similar to the producer, the consumer also goes ahead and first builds the application. It creates the published version of the DLL or the output, and then using the ASP.NET Core runtime image, it publishes the results, or it creates a runtime version of the image or the container. Once these two images are built, I will push them to the Azure Container Registry, which is the private container registry, and then we will deploy it onto the AKS cluster. So let's first start with Docker, and let's see how we build the images. So let's look at what are the Docker images I have on my laptop. Currently, if I run the Docker images command, we can see here that there are no images existing. So I want to start right from the scratch, where you don't have any image available and you're starting from ground up. So let's go and start with the building of these images. So if I just list down all the files here, you will see that this is the Docker Compose build YAML file, which I'm using to build both my producer and consumer application images. So let me go and fire the Docker Compose command and specify the file name as this Docker Compose build.yaml file, and I want to build the images. So what this will do is, if you've worked with Docker in the past, you know that Docker will try and connect to the Docker hub or whichever is the container registry we are using to pull these images, the base images, and then it will build the application and it will write the application specific layer on top of the build image or the base image. So here we can see that the first step of my producer custom image build has started, and it's pulling the Microsoft.NET SDK image from Docker Hub. This will take some time because the image is slightly bigger in size. Once the image is pulled, we will see what is the size of the image. So I'll let this process continue until all the images are pulled and my custom images are built, and then I will come back. Finally, there we have it. Now both my producer and the consumer images have been built based on those base images of .NET Core 2.1, and let's verify that we have these images available locally. But before that, what I want to do is I want to find out how much time did this take, the whole process. So I'm going to use one of the PowerShell feature, which is to get the history of the command which was run previously and find out how much time did it take. So I'm running get history command count1, which is the last command which was executed, and I want to find out the total execution time. So I can say command end execution time minus command dot start execution time. This will give me the total time taken. So we can see here that it took 12 minutes 55 seconds, so almost about 13 minutes to complete downloading the base images and then building the custom producer and the consumer images. So let's verify that we have those images locally available now by running docker images command, and here we can see that we do have the images available. So let me remove these temporary, the none images, and keep only the ones which we need. So I can run docker system prune command here to prune the temporary images, and if I remove the temporary images, we gain about 135 MB of space, but apart from the space, we can just look at the images that we built or we need for our application. So you can see that the first two images, the TechTalks consumer and the producer, were just built about 9 minutes and 2 minutes ago. The size of these images is 357 MB for the TechTalks consumer and producer is 257 MB. If you look at the base images, so the first one is aspnetcore build image, which is the image for with all the build tools for ASP.NET Core. This is 2.2 GB in size, and the runtime image of that, the equivalent version of the runtime image, is 347 MB. But if you look at this, these have been built almost 2 years back, 22 months or close to 2 years ago. I've been using this same set of images for last couple of years, and since then .NET Core has gone a lot of changes, and now we are at .NET 5, and the .NET 3.1 or 3.0 version is ready for production. So what I want to do is upgrade these older images, which are quite old, to the newer version of the image. We also look at the .NET version of the SDK or the image, base image. This one is 1.73 GB in size, and its equivalent runtime image is 255 MB. So now what I want to do is push these images to my container registry, which is the Azure Container Registry. I've already created a container registry, and I want to push these images to that container registry. So I can use the same docker compose command and use the same file, which is docker compose build.yaml, and instead of building, I would like to push these images now. When I do the push, since I am using the fully qualified name ngacr registry.azureacr.io, these images will be pushed to that container registry. So you can see that the error is coming here that I have not authenticated myself. So let me go and authenticate myself against that container registry. I need to give the name, and the name is the container registry name. So using this command, I will be able to authenticate myself against this private container registry. So now we can see that the login has been succeeded. And if I try the same command again, let's just clear this first. And let me run the push command again. So now it's able to push the images to the container registry. So here we can see that there are 2 layers of this image which has been pushed, while there were 4 layers which were already existing. This is because I had pushed this version of the image while testing, and this will not give us a clear picture how much time does it take to push the images. So what I will do is just to have again that complete time or the overall time which is required for a fresh setup, let me go into the container registry and delete those versions of the images. So this will simulate the scenario where there is nothing in the container registry and we are trying to push the new version of the image for the first time. So now if I refresh, we see that under the repositories in my AZACR or ngACR container registry, there are no repositories or there are no images currently. So let me go and try to push these images again. So this is a scenario where we are pushing a fresh image, a custom image for our application to a private container registry. So let's see how much time does this take to push those producer and the consumer images. So you can see that there are multiple layers in the image which is locally tagged. So currently it's trying to push the techtalks.producer image with the tag RabbitMQ-Keda 2.1. I'm using 2.1 to highlight or specify that this is 2.1 version of .NET Core I'm using, and when I upgrade the image to 3.0, I will tag it as 3.0. Okay, so the first image for the producer has been pushed, and now we are pushing the consumer image. So like we did for building of the images, let's try to see how much overall time it took to push a complete fresh version of the image to the container registry once this push is successful. So both the images have been pushed now. So let's go back and look at the command execution time once again. And here we can see that it took close to 2 minutes, 1 minute and 41 seconds. So now let's go and deploy this image onto the AKS cluster. So I've already provisioned AKS cluster beforehand, and I have deployed, or I've tested deployment onto that cluster. So here is the Octant, which I use to visualize the state of the cluster. It's a tool which gives a nice visualization of the Kubernetes cluster, and I did a video earlier showcasing what are the different features of Octant. So let's look at the pods which are running. So right now we see that there is the RabbitMQ, which is the RabbitMQ itself pod which is running. This is the RabbitMQ service or RabbitMQ cluster, and then we have the two producers running. So if you had looked at any of my earlier videos, you know that I have handy PowerShell scripts. So let me go and delete or tear down this particular deployment, whatever has been currently running on the cluster, and we can on the Kubernetes CLI or kubectl that there are no pods running currently. So if I run get pods command with the watch flag, it will show us what are the pods running. So currently the application containers have been deleted as part of that teardown command which I ran, or teardown script which I ran just now. We only have the RabbitMQ cluster running. So let's go and redeploy the application. So for deploying, I have deploy tech docs. The script will deploy the producer and the consumer, all the manifest that is required. And once this is successful, it will pull down those images. So we can see that it is already starting to deploy the consumer and the producer. And if we go back to the Octant and try to see which version of the image the producer and the consumers are trying to deploy. So in here we can see that I'm looking at the let's go back, pods, okay, producer deployment, and I want to look at the image. So we can see here that it's now trying to deploy this RabbitMQ KEDA 2.1 version from the NGACR container registry. So this is the image that we pushed just now, a few minutes back, and this is getting deployed onto this AKS cluster, and they're already running. So if everything is fine, then we can go into the services and try to generate some workload. This is just to make sure that everything that we deployed runs fine. So I'm using Postman here to generate the workload, and Postman will go and pump in 1500 messages onto the RabbitMQ queue, and then that consumer will start picking up those 1500 messages. So we got status as 200 OK, which means the messages were sent to the queue. And now if we look at the pods, we should see the auto scaling kicking in and the number of consumers scaling based on the number of messages which are remaining to be processed. So since we have a watch on the terminal, we can see it here as well. So shortly we should see the consumers increasing. There is a slight delay of about 1 minute, and that's the interval after which the autoscaler starts to look for any changes in the state of the cluster. So now we can see that the autoscaler has kicked in and the number of consumers have started increasing. So while this is running, let me go back and start making the changes to upgrade the image. So what we saw here is we are using the 2.1 version of the ASP.NET Core in these images. To upgrade this to 3.0, I will start with the Docker Compose first. So let me go and change the tag. Instead of 2.1, I want to use 3.0 as the tag for new images. which I will be building using .NET Core 3.0. So this upgrades or this changes the image which will be generated as part of our Docker Compose build. Next thing is I need to update the Docker file which is used to build those images. So the older version was using ASP.NET Core build as the build stage or as the base image. I'm going to delete that and I'm going to replace that with the new version of .NET Core SDK 3.0 base image. Once the base image is changed and once the application is built, rest of the things are same. I don't have to make any change there. Then I go and change the runtime version of the image as well. So here again, I'm updating to the .NET Core ASP.NET 3.0 version of the runtime image. So we can see that the SDK uses SDK 3.0, whereas the runtime version uses ASP.NET 3.0. That is for the consumer. Same way for the producer, I will change the 2.1 300 SDK and upgrade it to the latest version. So in case of 3.0 or .NET Core 3.0, the base image is same as well as the runtime image. So we don't have different versions for the ASP.NET Core API and the exe type. I can use the same base images and the runtime images in both these type of projects. So I've deleted the older 2.1 reference and I have changed the base image for producer now to refer to ASP.NET 3.0. So with this, we have changed our multi-stage Docker build. Along with the multi-stage Docker build, we also need to make some changes to the project files. So let's go and start with the producer first. In the producer, 2.1 version was referencing Microsoft ASP.NET Core app, and in 3.0 this is included by default. We do not have to include this specifically. The next change we have to do is to update the target framework. So currently the target framework is using the moniker Netcore app 2.1. I'm going to delete this and replace it with 3.0. So once that is done, our project file is upgraded, or the csproj file is updated to 3.0 version. There are also some changes because of the way the changes have been done to the underlying infrastructure layer of .NET Core. So in the new model, we have the Microsoft extensions hosting. When it comes to the hosting models, there were different hosting types, and in 2.1 version we were using the services and adding reference to add MVC. If we don't need all the MVC plumbing or the middle tier services of MVC, one of the good feature of 3.0 is we can just use the pure 3.0 features. We don't have to have all the MVC plumbing required. So in this case, I'm removing the services.addMVC method call, and I'm adding a new call or a new reference to say services.addControllers. So I just need controllers here. My API does not have any visuals or any UI. It just needs the controller part. So I'm adding the addControllers method. And same way, in the old version, we were using the iHosting environment as one of the input parameter to the configure method. In the new one, this has been changed, and I can remove the reference, or I'll just comment it for now. We are using iWebHost environment. The other change we have is, again, use MVC. We comment that we no longer need to use the MVC plumbing, and that is replaced with URL routing. So we can replace use MVC with use routing, and then we specify the use endpoint. And since we have the controllers here, I can specify individual controllers, or I can just say endpoints.map all the controllers using .mapControllers method. So with those changes, our producer is ready, or producer is upgraded. That's the only change I had to do to make the producer work, or rather 3 changes we had to make. Compared to the producer, the consumer is much simpler because consumer is an exe and it doesn't have any MVC features. So here I changed the moniker to point to 3.0, the output type. So if you see here, the output type is exe and we are changing the target framework to .NET Core 3.0. Apart from that, no other change is required for the consumer. So now we have the producer and the consumer upgraded, and we have also changed the Docker Compose build tag. The last thing we have to do is in our Kubernetes manifest files, we have to update the image version, because now we would be tagging the image as 3.0 instead of 2.1. So let me go and change the producer deployment spec definition to refer to 3.0 tag. Same way for the consumer, instead of referring to the 2.1 version, let's go and change it to 3.0. So we've made all the necessary changes. Let's go back and see what is the status. So we can see that all those 1500 messages have been consumed by the scaled up consumers. We had 30 consumers coming in and consuming all those 1500 messages from the RabbitMQ, and we see that these consumers have started terminating because of the auto scaling. So when there are no messages to be consumed, the KEDA framework which I'm using here, it automatically starts to scale down the consumers. So now let's go on to our creation of the images, and let's again recreate these images with the new 3.0 base images. So let's see which are the images currently available. So currently we have those 6 images from the 2.1 framework. Again, to start from the scratch, we already have pushed this version of the image to the container registry, so I can go ahead and delete these local images, so that when I start building the 3.0 version, we are again starting from scratch. So we have like to like comparison when it comes to the timing. So let me go and clean up all these Docker images. Docker RMI, and I want to clean all the images. So Docker images -a and -q. So this will go and delete all the local images that we have. So all those 6 images which we are seeing currently should be deleted. And if I do run the Docker images command again, we should find empty list return. So we are again back to square one, where we don't have any images locally now. So now what I'm going to do is, let's verify once that we have in our build upgraded this to 3.0, and in our Docker files which are used for generating those images or building the custom images, we have also changed to 3.0 as the base image for both the SDK as well as the runtime. So we are good to start, and let's go and use the Docker Compose command to build those images again. So file Docker Compose build.yaml, and I want to build the images again now. So this again will take some time because it needs to pull the latest version of those base images, and I will stop for a while these images are getting pulled, and I will use the image editing to come back when the images are tagged successfully. So now the two images have been built and they have been tagged. Let's see how much time did it take to build those images. So let's go back and run the same history command to get the time and the command execution time. So we can see here it took 5 minutes 27 seconds. So let me just go and record the time. 5 minutes 27 seconds. So that's what we can see here is there is almost 57% reduction in the amount of time it took to build the first version of the image, or to pull the latest version of the images and build the custom version of our application. So let's go and push these images now to our container registry. So I can run the same command, and instead of build I need to fire the push command here. So what we see here is when it is pushing these images, it is pushing all the layers, because this version of 3.0 version image, or the base image, doesn't exist in my container registry. So the first time it's pushing each and every layer onto the container registry, and when it comes to the second image, the one for consumer, it already has some of those layers, because we are using the same base image, so it's able to push this faster. So if you find the amount of time it takes to push a fresh version of 3.0 image, we can see that it took just about 47 seconds. So if I go back here and update the timing, this will be 47 seconds, which is, and this was 1 minute 47 seconds earlier, not 1 minute 6 seconds. So it is 107 seconds total. So we have about 56% gain in the time it takes to upload the images to the container registry. Now let's go and deploy this version. So let me run the teardown script to delete what is currently running on the AKS cluster, which is 2.1, and then deploy the new version. So if I go and look at the images here, let's restart this. So get pods and watch. So we can see that it's now creating the consumer and the producer with the new version of the image. We can also verify this by going on to our Octant UI and looking at which version is used by the producer. So I'm looking at the details of producer, and we can see that it's now pulling the RabbitMQ KEDA 3.0 version of the image, or tagged image. So the older consumer images, they are being terminated, and the new version is getting pushed here. So I'll not go and generate the workload again, because if the images are deployed successfully, these will be working fine. So in the interest of time, we'll go back to the presentation and let's see where we left earlier. Before I go back to the presentation, let me also show one more thing, which is the size of the images. That's something we did not verify, or we did not look at after upgrading to 3.0. So if I run the docker images command again, now we see that we have again 6 images, but let's prune the temporary ones. So Docker system prone. So the temporary images have been deleted, and if we run the docker images command again, we see that now we have only 4 images, because we have the SDK image and the runtime image, which is both used by or both our custom images. The TechTalks consumer and the producer are using the same version of the image. There is no difference in terms of the .NET Core API and the exe. They both work with same SDK and they both work with same runtime version of the image. And now if we look at the size of the image, we see that the SDK image is only 690 MB and the runtime image is 207 MB. And our custom images, the producer is 216 MB in size and the consumer is only 214 MB. So now let's go back to the presentation and quickly look at what did we see so far. So the .NET Core Docker base images 2.1, this is what we saw earlier. We have 4 different base images, one for the exe and one for the build. And the same way there is an equivalent one for aspnetcore and the runtime version of that. And here are the sizes. So if we look at the build image with the build tools, the biggest one is 2.02 GB in size, and the runtime version is close to 350 MB, whereas the .NET SDK is 1.73 GB and the runtime version of that is 255 MB in size. And the size of our application containers based on these runtime version of the images is 357 MB and 257 MB. When we upgrade this to 3.0 version of the base images for .NET Core, we have only 2 versions of the images or the base images. The SDK is 690 MBs only and the runtime version is 207 MB. And because of this reduction in the runtime version, we also see the reduction in our application containers. So now the TechTalks consumer is 216 MB in size and the producer is 214 MB in size. So in summary, we see that when we upgrade from the older version, almost like 2 years back version of the base images 2.1 to 3.0 version of the images, we get some performance benefits in terms of improvements. First one is we get almost about 75% faster build for fresh or the first time build. This is based on my previous test which I did. In this particular test, if we look at the result, we got around 57% reduction in the time which is used, which is taken for building the images first time. When it is done for the subsequent times, in the earlier runs, I found about 50% improvement. So what happens here is, since the images are already downloaded to my local machine, Docker will not pull the base versions of the image again. It will only go through the process of building the custom images using those base images. So even in this, we see about 50% improvement. Overall, there is about 70% reduction in the size of SDK image, and the runtime image is about 40% smaller in size. And when it comes to the application containers, which are built using these runtime version of the images to be deployed in target environment, in my testing, I found about 15 to 40% reduction in the container sizes of the images. So when we have the smaller image sizes, it helps in the faster deployment, because the amount of time it takes to upload those images to the Docker Hub or like private container registry. In this case, I was using Azure Container Registry. That would be faster because we are using smaller size of the image, and the amount of time it takes to upload that smaller image is reduced. It also helps in reducing the cost, because if we look at the private container registry, they charge the costing model is based on the size of the images that we store. So if we are storing smaller sizes of the images, that means our overall cost would be smaller. So with this, we can conclude that we should upgrade to the latest version of .NET Core images and get these benefits. I hope that this session was useful. If you want to look at the source code for this demo, it's available on my GitHub repo at PDTechFest 2019. I also have the links where you can find me on social media using LinkedIn or Twitter. My Twitter handle is at Nilesh Gule. Similarly, I also blog at handsonarchitect.com, and this is the YouTube channel I have. So I hope that you found this session useful. If you found it useful, please hit the like button and also subscribe to the channel. Thank you once again for watching this. I hope it was useful.